Hey 11s, welcome back. Last lesson went through exercise 2A and exercise 2B on looking at the coordinate geometry when it comes to midpoint, distance, also linear relations in terms of the gradient of a straight line. Today we're going to be putting that into practice when it comes to the equation of a straight line. However, I do want to go through the now question. Today's question is find the distance between -6 and 3 and the coordinate for -11. Please pause the video. I'll give you guys some time to walk through this. Alright, awesome. Let's go through this question. So we got our two coordinates. First thing we do is let's allocate x1, x2. So let's get x1, x2 over here, and we've got y1, y2. Using our distance formula, remember it's based off Pythagoras. I'm going to go ahead and say distance equals to square root of x2 minus x1, square root plus y2 minus y1. And of course, we're going to square that as well. Now let's go ahead and substitute our numbers. So I've got square root of x2, so that's 4. Take away x1, which is -6. Square that, plus y2, which is -11. Take away y1, which is 3, and square that. We end up with 4 minus 6 gives us 10. Square that, we get 100. And then we get -11 minus 3, which is -14. Square that, 196. We add that together. I get the square root of 296. You put that in your calculator. We get 17.21 if it's rounding to 2 decimal places. Once again, if you simplify your fraction, your square root, it's all fine. But in a calculus situation, or it's asking you to have it in a certain number of decimals, we should be writing in decimals. Awesome. Let's continue and look at exercise 2C, which is our equation of a straight line. If you're not finished copying the question down or the answer down from last question, feel free to watch this video again. So we looked at this last year actually with the different forms of a straight line. So we've got gradient intercept form, and then we've got point gradient form. I'm actually going to go through gradient intercept form. This is my personal preference. I prefer to use this form over here. If you want to go ahead and use point gradient form, that's also welcome. However, do note that both of the equations, or the forms rather, give the same equation. So it is possible to transpose each equation to form the other form, but one of them should suffice. So a gradient intercept form uses exactly that, or rather it shows exactly that, the gradient and the intercept. So in which case we have y equals to mx plus c. This should be extremely familiar. We've got m with our gradient, so that's our rise over run from last lesson. And we've got c, which is our y-intercept. Now, for now, it's safe to say that c is our y-intercept. When it gets to more complex mathematics, particularly with our quadratics or our polynomials, for those of you that have heard those terms, it doesn't actually give us a y-intercept. However, for now, do note it is y-intercept, or rather when x equals to 0. So the first question is find the gradient and the y-intercept of the line y equals to 3x minus 4. This is a straight extracting information from the equation question. So we're going to go ahead and set m, which is based off our formula. Remember, y equals mx plus c. We've got m equals to 3, which is our gradient, and our y-axis, or our c, equals to -4. That's it. Let's move on. We've got to find the equation of the line with the gradient -3 and y-axis intercept 5. So I know that m equals to -3 because that's what it says in the question, right? So -3 is what I've got, and the c equals to 5. That's what the y-axis tells us. Now we're not done. It says to give the equation of the line. I'm going to use my gradient intercept form because that's what we've been given, the gradient and the intercept. I'm going to say that y equals to, using this form right there, m, which is -3, x plus 5. Y equals -3x plus 5. Apologies if I am speaking too fast. Okay, the last question for this type is state the gradient of the y-axis intercept of the line 3y plus 6x equals to y. Now this one isn't strictly looking at gradient intercept form, but I think it's a really good example. For this one, what we need to do is we actually need to transpose the equation into gradient intercept form. So remember, we're looking to get the form of y equals to mx plus c. I've got 3y plus 6x equals to 9. I'm going to go ahead and say the first thing I need to do is move it so all the variables are one side except for y. So I'm going to subtract 6x on both sides. 3y equals to -6x plus 9. Okay, hopefully that makes sense. I'm going to go ahead and divide both sides by 3. I get y equals to negative 2x. So negative 6x divided by 3 is negative 2x. And I'm also going to divide 9 by 3 in order to get positive 3. Now we've got our gradient intercept form where I've got y equals to mx plus c. You can see that my m is going to be negative 2 and my c is going to be positive 3. So the gradient, I'm going to go ahead and write on this side over here. So gradient equals to negative 2 and my y-intercept is equal to 3 or positive 3. Awesome, so that's gradient intercept form. I'm going to now look at point gradient form. So our point gradient form, we actually have the equation of y take away y1 equals to m bracket x take away x1. So just as the form states, we actually are provided, or we're looking for, the point and the gradient. So our point actually comes from x1, y1, something that you should be generally quite familiar with. So x value goes in here and our y value goes there. Same idea with our gradient being over here and the y is over here. You'll notice that it's actually very similar to what our gradient intercept form is, and if we wanted to, we can just transpose that over there and expand those brackets in order to get our gradient intercept form. However, in this case, we can just stick with the point gradient form. Let's go ahead and put that into practice. So we're going to find the equation of the line which passes through the point negative 1, 3 and gradient of 4. We can just sub that in. I know that I've got a point, I know that I've got a gradient, so point gradient form it is. I've got the point negative 1, 3. So I'm going to go ahead and actually write the equation first. Y equals to y minus y1 equals to m bracket x minus x1. I'm going to substitute my points. So instead of writing x1 and y1, I'm going to write negative 1 and 3. So I see that I've got x1 over here. So I'm going to replace x1 with, there we go, with negative 1. That's from the question. I'm going to go ahead and replace y1 with 3. So I'm going to replace that and write 3. Now I get y take away 3, oh, we've already done that, equals, let's write that through, m bracket x plus 1. However, my gradient is also 4. So I'm going to now replace m with 4. Okay. From there, I'm going to go ahead and add 3 on both sides. Y equals to 4x plus 1, and then add 3. I'm going to expand the brackets. Y equals to 4x plus 4 plus 3. You'll notice where we're going. Y equals to 4x plus 7. Now you'll notice that it's actually our gradient intercept form. This one right here, we've got y equals mx plus c again. However, for our point gradient form, I'm going to say that we're going to stick with this one right here. That will suffice. This as our answer right here if the equation says to leave it in point gradient form. Now, I do want to note that for assessments, unless it specifies which form it needs to line in, you can leave it in any form you like as long as it's simplified. In this case, it's simplified. We can leave it there. If you'd like to move it forward into gradient intercept form, into this response over here, that's also valid. However, we'll leave it in that boxed answer. Next question before our last one. Find the equation of the line that passes through point 3, 2 and has a gradient of negative 2. First thing I want to do, once again, is identify. I've got a gradient, which means that m equals to negative 2. I know that x1 equals to 3, that's our point over there. And I've got y1, which equals to 2. Now, let's go ahead and write an equation. Y equals to, so not y equals, y minus y1 equals to m bracket x take away x1. That, once again, is from this formula up here. I've missed it. There we go. This formula over here. Now, I'm going to go ahead and slowly substitute values. Instead of writing y1, I'm going to write 2. So that's this one from over here. So 2. Instead of writing m, which is our gradient, I'm going to write negative 2. And instead of writing x1, I'm going to go ahead and write 3. So y minus 2 equals to negative 2 bracket x minus 3. That gives our point gradient form. I'm going to go ahead and try and solve this, transpose this, expand, etc. in order to get our gradient intercept form. I'm going to expand, I get negative 2x, and then negative 2 times my negative 3, which gives me positive 6. Y equals 2, I'm going to add 2 on both sides, negative 2x plus 8, and that's our final answer. You'll notice that over the last couple of questions, we've been given a gradient and a point, but what happens if we've been given 2 points? So this is essentially the ultimatum of what these exercises are up to. We're looking at can we find the gradient from given points and then use one of the points to find that equation? So either option's fine. Once again, I'm going to reiterate, either form works as long as you get the correct answer and correct equation in the most simplified form. So I got the points y, -2, and 1, -2, and 3, 2. I'm going to go ahead and use our formula for our gradient where rise over run gives our m. So I got rise, or in other words, y2 take away y1 over x2 take away x1. y2 is 2, if we're allocating this as coordinate 2, and this is a coordinate 1. So 2 take away -2, leaving that in brackets, and then x2, which is 3, take away 1, and that gives us 4 over 3, not 3, 2, which gives us 2. And therefore, m equals to 2. Bam, that's our first bit of information, okay? Our second bit of information, we're going to go ahead and use one of the points. I'm just going to use this point up here. Now, the question is, why does it matter which point we use? Well, in reality, it doesn't actually matter which point we use, because both of those points actually sit on the same line. And what we're looking for is the equation where the line passes both those points, or passes through both those points. So it doesn't matter which one we use, we should just pick one that makes our life easier. I'm going to go with 1 and -2, just because they're smaller numbers. So I'm going to use the gradient intercept form. I'm going to write GI form. This is the y equals to mx plus c. So I got y equals to mx plus c. I'm going to go ahead and replace letters. I'm going to replace m with our gradient, which is 2. I'm going to replace c. We don't know what our c is. So it's actually not preferable to use gradient intercept form. We don't have our intercept. So let's scratch that. Let's go ahead and use our point intercept form. Okay, so I've got y take away y1 equals 2 m bracket x take away x1. So that should look quite familiar to you. Let's go ahead and solve this. I'm going to substitute, I'm going to use this coordinate again. I'm going to substitute substitute y1, replace that with our y1 coordinate, which is -2. We're leaving that in brackets. And then I've got x1, which is 1. I'm going to replace that over here. And I should get y plus 4 equals 2. I'm replacing our m. Now instead of writing m, we're writing 2. Bracket x minus 1. Okay, so from there, I've got y plus 4 equals to 2 bracket x minus 1. We can go ahead and change it into gradient intercept form from here. Y equals 2 bracket x minus 1. So take away 4 from both sides. I'm going to go ahead and expand that, and I get y equals to 2x minus 2 minus 4, which ultimately gives us the answer of y equals to 2x minus 6. Hopefully that makes sense. Let me know if you have any questions. Otherwise, get started working on exercise 2C questions. If you finish early, please make sure you finish updating your resource book, making sure it's up to date and neat. I'm going to be checking it as I come around back to class on Thursday. Good luck.